Our journey begins with a common modern dilemma: mental rigidity. Neuroscientific studies reveal that 73% of adults exhibit fixed thinking patterns by age 30. This scene explores how our brains default to familiar neural pathways, creating invisible barriers. The prefrontal cortex, responsible for flexible thinking, actually shrinks when underused. MRI scans show that repetitive thoughts physically reinforce certain neural connections while others atrophy. This biological process explains why creative solutions often feel inaccessible. The first breakthrough occurs when we question our own cognition. Harvard research shows that 68% of creative insights emerge during moments of metacognition. Thinking about thinking. This scene highlights the Einstühling effect, where prior knowledge blocks better solutions. Studies at MIT demonstrate that simply recognizing this mental block increases problem-solving success by 40%. The flickering light bulb represents the brain's anterior cingulate cortex activating, the region that detects cognitive conflicts and sparks curiosity. Here we uncover neuroscience's revolutionary discovery: neuroplasticity. Contrary to old beliefs, adult brains can rewire themselves. London taxi driver studies show their hippocampi grow significantly after spatial navigation training. This scene explains how learning forms myelin sheaths around frequently used neurons, making those pathways 300% more efficient. Remarkably, mindfulness meditation has been shown to increase cortical thickness in just 8 weeks. The brain's plasticity allows us to literally think ourselves into new patterns. Breaking habits physically alters brain structure. University College London found that new habits form in 66 days on average. This scene demonstrates behavioral activation, using physical actions to create mental change. Research shows using your non-dominant hand for simple tasks increases prefrontal cortex activity by 22%. The basal ganglia, our habit center, can be reprogrammed through consistent novel actions. Even small changes like rearranging your workspace triggers neurogenesis, the growth of new brain cells. Uncertainty triggers remarkable brain adaptations. Princeton studies reveal that ambiguous situations activate the dorsolateral prefrontal cortex 35% more than clear scenarios. This scene explores how tolerating uncertainty increases cognitive flexibility. Brain scans show that people comfortable with ambiguity have stronger connections between the hippocampus and prefrontal cortex. The fog represents the brain's default mode network, which becomes highly active during uncertain states, often leading to breakthrough ideas. Innovation thrives at disciplinary intersections. Stanford research shows that 82% of breakthrough ideas combine concepts from unrelated fields. This scene highlights how the brain's association cortex works, linking disparate concepts to form new ideas. Studies reveal that polymaths have 23% more dendritic connections between brain regions. The mind map visualization represents the brain's connectome, the vast network of neural pathways that combine memories, skills, and knowledge in unique ways. The flow state represents peak brain performance. EEG studies show flow combines high alpha waves, relaxation, with mid-range beta waves, focus. This optimal state increases neurochemicals like dopamine by 250%. The scene demonstrates how flow temporarily deactivates the prefrontal cortex's inhibitory functions, creating a state of transient hypofrontality where ideas merge seamlessly. Remarkably, just 20 minutes of daily flow can increase neuroplasticity markers by 17% over 6 weeks. Mistakes physically reshape our brains. MRI studies show that learning from failure activates the anterior cingulate cortex and ventral striatum more than easy successes. This scene reveals how the brain's error positivity response, a spike in electrical activity 50 to 150 milliseconds after mistakes, enhances future performance. Neuroscience proves that viewing failures as data increases myelin production in relevant neural pathways. The crumpled paper transforming represents synaptic pruning, the brain's process of strengthening useful connections while eliminating others. Group thinking creates unique brain states. Research shows that effective brainstorming synchronizes participants' brainwaves, neural entrainment. This scene demonstrates how social interaction triggers mirror neurons, specialized cells that activate both when we act and observe others acting. Studies reveal that diverse teams show 45% more prefrontal cortex activation than homogeneous groups. The puzzle represents the brain's theory of mind. Network, the system that helps us integrate multiple perspectives into coherent solutions. Our journey culminates in transformed cognition. Longitudinal studies show that practicing these techniques increases gray matter density by 16% in creative problem-solving regions. This final scene reveals the brain's default mode and executive networks now work in harmony. The fractal universe represents the brain's connectome, with its 100 trillion connections, capable of more permutations than atoms in the universe. Neuroscience confirms that creativity isn't fixed. It's a muscle that strengthens with deliberate training and neurochemical nourishment.